Thank you and good morning. Yes, I used to travel all the time, like 200 travel days a year or so. It has been a rough 20 months now, but I think they finally let me out of the box again. So let's dive into the topic. On the bleeding edge of OpenTelemetry or OpenTelemetry, who knows in general what OpenTelemetry is? Okay, you have come to the right talk. So let's see where we are and how to arrange that. Just quickly about me, I work for Elastic, the company behind Elasticsearch and some other stuff. My official title is something like developer advocate, so I mostly run around to kind of like organize stuff and talk about the stuff we do and try to put out fires, just like everybody else. So, before diving into OpenTelemetry itself, just to kind of like set the stage of where we are and where all of this fits in, I assume that everybody is using logs, right? More or less to some degree. Maybe. Oops. Okay. I assume that everybody more or less uses logs. And the nice thing about logs is that you have this chronological record of events. If you have put the right log statements where you want them, then it will spit out the information that you want to see. Which is already kind of like the caveat, like if you put the right log statement in the right place, which can be slightly annoying. If you didn't put them, and then you have to redeploy, write more log messages, yeah. Sometimes that happens and you have to do that. To get the logs, maybe you have used something like this, so that's one of many options. That's kind of like our take, and you've probably seen this one, and then in the end it looks something like this. But in the end, you know, something spits out logs, and it has some information, and then you can search in those logs, and you can more or less figure out what is happening here in this application, more or less. The thing that is kind of important for logs, and what I think has given logs a bit of a bad reputation at some point, is when you had like these very human-readable log lines, and then you try to make sense out of them in a more, well, automated fashion. So what you're often trying to do nowadays is going from logs to something like events with more structure and context. So for example, if I change my login in an application, and originally the log message was just Philipp failed to log in with password, and then I blank out the password. This is nice for humans to figure out that Philipp failed to log in, but no machine can make much sense of that. If you add some more structured information here, like this, you will be able to get much more out of these logs in an automated fashion, or if you have a lot of events happening. Because then you can figure out what kind of event is this. This was a login failure, and then you can already calculate something like the ratio login failure to login success, and then you see, oh, we broke the login because all the logins are failing. Or you can see like, we have a login failures for a specific name, because somebody is trying to brute force the Philipp account. Or you can see like, oh, we're getting lots of bad requests from one specific IP address, and we should probably block that IP address. So if you put or make your logs a bit more clever and structure them more, you will be able to get much more relevant information out of them. This is nice, but this is, if you have millions of log events an hour, it's very hard to make sense of what is really happening in your system and how you should work with that. So if you have that additional metadata and have more like events, it will make your life a lot easier. Anyway, enough about logs. Metrics. I guess most of you use metrics in some way or another. Yeah, maybe. The idea of metrics is you have this periodic measurement of some numeric value. And the nice thing about metrics is generally that you can aggregate them and that you can see for the interval that I'm interested in, this is what I'm seeing, or whatever the average or whatever P99 was for that specific time frame. So it's very good to tell you in an overview of like, how is my system behaving, what is the response time, what is the error rate, things like that. But it's very bad at telling you why something is working or not working. So if you see the latency is going up, or that your error rate is going up, the metrics will tell you that, but it's very hard just based on the metrics to figure out why or what happened. And then you might go back to the logs to see where that is coming from. Maybe you're using something like Prometheus to see what's happening in your metrics. We have our own take, but in the end, you have something where you see, I don't know, this is my CPU usage, and this is my memory usage, and this is the network and the load, and in your application you see the failed and successful events, and maybe you have like latency and all these things, and you can just aggregate that and see how your system is behaving like overall, just as an indicator. Besides metrics, what else might you be using? Traces, yes, we'll get to traces in a moment, but we're not there yet. One other thing I like to throw in here is uptime. Is anybody using some uptime measurement? Very few, okay. It's not part of the classic logs, metric, traces, but I think that uptime monitoring is something that many do as well. Some even do synthetic or proactive monitoring. Is anybody doing anything like that or knows what those are about? Recently I got into a discussion where somebody said like, well, we have always been doing that, we just never have given it that fancy name. But what synthetic or proactive monitoring is basically doing is, you have a very common flow on your system, like you have a web shop and you put something in the cart and do a checkout. And you have some automated way to run through those steps, so your automation fails before your users do. Because with the logs and the metrics that we have seen before, basically you're waiting for your users to fail, only then to spring into action and see like, oh, my users are running into failures, I need to fix something. And this is like a predefined flow on your app to say like, oh, this should be working, but it isn't, so I will start looking into this before any users are actually affected. And yes, it has the fancier name, but lots of you have probably been doing that to some degree before, that you ran through some steps one way or another to see how things are working. I don't know what you're using. There are various tools like Pingdom or whatever. We have our own take, and I have broken almost everything here, so you can see, I don't know, what is working. You can also see, for example, stuff like, ooh, TLS certificates are expiring, which is also one of these common things that you always forget to do. So uptime monitoring and some additional checks around that can be very helpful. Finally, traces is kind of like, maybe it's the least used approach, is also often the most expensive one because you need to collect so much data. And here the idea is you see it more from, like on the logs, for example, are very much on the component view. It's like you have rolled out one app or one part of your app and it's spitting out some log events. Whereas tracing is more like taking this view of on a per request basis. So a user request is coming in and then you trace that entire request throughout the system that you're watching. So you have a lot more context of what is happening. And we'll get into why and how in a moment. Maybe you're using one of these, and normally Jaeger doesn't have the very red eyes, but I think it's also a nice touch to it. So Zipkin and Jaeger are two very common tools for that. They can have various backends, or there are multiple takes on that on the front-end side as well, and I'll show you something like this a little later. Anyway, so tracing, or sometimes called APM for Application Performance Monitoring, or sometimes distributed tracing, I won't make much difference in the naming. I know that some people are very picky and say like APM was for the monolith and nobody's using that today anymore and everything we do is distributed tracing. But in the end, I think pretty much all the tooling that is out there had to kind of like change and adapt. So it is pretty much distributed tracing for pretty much any modern system. So I won't be too picky about the name going forward. Wikipedia has the not so helpful definition, the monitoring and management of performance and availability of software applications, which yes it does, but let's look at a slightly more concrete example. So back in the days, or I don't even want to say back in the days, if you have this is still perfectly fine, but in simpler times you had your user and you have the cloud and then you have my monolith, and then you maybe have a load balancer to spread out the load, and then you have maybe one database. So you have a request coming in, goes to the database, fetches some data, and then you get the response back. This one is easy enough. Like if your application here spits out some logs, you can probably follow along of what is happening here. Now, we all wanted to move away from this, right? To have more fun. And nowadays it's looking something like this potentially. which I always say is the much better time for vendors, because now you need much more tooling. It's not just like you have one service and that one service spits out some logs and it makes sense, but it's like one request is all over the place and you added more databases and services are talking randomly to each other, or maybe not randomly, hopefully, but your services are talking to each other, and then something comes out at the end. And here, maybe if you like murder mysteries, this might be much more fun, but it is also much harder to debug, because this here spitting out some logs is very hard to correlate with these others. It's also very hard to say like what is slow here, because it could be anywhere, or what is even throwing errors, because it could be this and that, and if you have so many components, something can be down and something can be up. And the state is just like a permutation of, like, if you have n service, it's basically n factorial in potential combinations. So things are getting much more interesting, or better for vendors, depending on how you want to see it. So here you probably want to have some more tooling around it. And that tooling could be, for example, that if you have a library that once the request comes in and gives it a unique ID, and then that unique ID is being kept as your requests wander through the system, and you put that unique ID in the logs, you can at least see what happened in one request and where it failed, and maybe some timing information. But tracing will be what gives you even more context and shows you not just like in one specific log event and then kind of like tries to correlate those, but shows you or captures the request comes in and then it comes out, and this is the response code. This is where it spent its time, and this is where it's potentially failed or didn't fail. So tracing will make it a lot easier to figure out what is going on in this confusing thing here, rather than just having to look at the logs of one specific system. And especially if you don't have centralized logs and you use, I don't know, tailf, grep or whatever, and you have this across many containers or systems, this will not be a lot of fun to debug, unless you're paid by the hour and you want to spend a lot of time on it, which is always an option. So it's all trade-offs. Anyway, so what do you want to do if you have this highly distributed application? And let's assume we have an application that has multiple parts, so it's a bit harder to debug. You want to get that context of the transaction. You want to reconstruct like that flow of like, where did the request come in and then how did it work throughout the system? And then you want to query and visualize those different transactions. And that's basically where tracing comes in to pick up those pieces. Just in terms of terminology, the trace is the record of a request, and it's a directed acyclic graph. So basically the request comes in and then it might fan out in your system, and at the end it's probably combined again and then the result drops out. But it's not just like one line that goes through it, but it could fan out into multiple services in parallel and then get you a result. So it's directed because the request comes in and comes out at the end, but it can take multiple paths or paths in parallel. Within a trace, you can have spans. It's a named and timed single operation, and it can optionally be nested again. So it's kind of like maybe something like a method call, for example. So you have the entire request and then it's broken into different spans to make sense of those. To ID all those requests, you have the so-called span context, and the so-called context propagation is when you attach that ID. So what normally happens is the request comes in, the first service that gets hit by that request gets a unique ID, and then that request carries the ID along as it works its way through the system. If you do HTTP calls, it's pretty simple. It's normally an HTTP header. If you're using queues, you need a different system to propagate those IDs. But the point is, normally the request comes in, it gets the unique ID, and then it carries the unique ID as it works its way through the system. And that's how you can combine it afterwards, by taking everything that has the same ID and say this was one flow. The problem then was, or is, there are lots of different libraries to do the tracing for you, and all of them generate different IDs. So what is Uber Trace ID? Which system is that? Yeah. Jaeger. Yes, that's Jaeger. So Uber is behind Jaeger, and I think the the HTTP header is still UberTrace ID there. So the ID they generate looks something like this. And then, for example, we have our own agents, and the IDs look something like this. And you can already see that these two would probably not make much sense in combination. So the kind of like the starting point was there is a set of libraries for different tools. And then you had to instrument all your applications with the same tooling because they generate different IDs or different types of IDs. And you cannot just mix and match them and they don't understand each other. Because something in here is, I think this is the version and this is how many requests are being collected. So this might be 1% or there are different things encoded in this actually. What is the request and what is the span. And they're all different between systems. So these agents won't be able to interact with each other if they use these different headers. Now you might say, this is all fine because I will use the libraries of one tool provider for everything and we're done. The problem starts when one tool provider doesn't support everything that you need. So maybe you at some point add an iOS or Android library or application to your portfolio and the vendor of your choice just doesn't have an iOS or Android integration. And then you suddenly cannot add tracing there. And people were like, but for different applications, we might have different libraries to instrument them. So how can we make all of these work together? And that's where OpenTracing comes in. And it's normally abbreviated OT, and it's not off topic, but it's OpenTracing. And then there is OpenTelemetry, which unfortunately also has OT. So that's normally abbreviated Otel, just to make the difference between the different OpenTracing and OpenTelemetry. So what OpenTracing, which kind of was the starting point for all of this standardization, did was, it's vendor-neutral APIs for tracing. So it says like, this is what we want to achieve. And this is, by the way, a very nice graphics also to show the difference between tracing and logs, because all of this is one request and the trace, and you can see this is the parent span where the request came in, and this is the first span, and then this one has a child span and another child span, and then it reaches out to another service, and you have more child spans here. And then these little vertical blue lines, this is your logs. So you can see the trace or request has like this entire scope of all of this. And then on the component level, you might be spitting out single log events in addition to that. So this tries to show that this is like on the component level and like individual pieces, but to get the whole thing, that's where tracing comes in. And it standardized what that tracing information that you can put in a header looks like. So it called it span context with a trace ID and a span ID. And then you have baggage items. Baggage items are like key value pairs where you can add any additional information to it that you want. So I could add a custom ID, a special ID, whatever tag I want, and then you just keep that property with it and can propagate it as well. And this is standardized how it's named in the headers. What OpenTracing does or does not is it's only API and headers. It's no wire protocol in or out band. So when I say in band, it's like the propagation within your application. How do I propagate the tracing information from one system to the other? Out band is to, once the request has been done, that you send to some central place all of that information that you have collected in the trace so you can recombine it at the very end. That's in and outband, and neither of those are standardized by OpenTracing. It's really the API or headers only, which kind of wasn't the full thing that people wanted. So then, for a short amount of time, W3C Trace Context was the thing, and that's basically doing trace content or passing trace information across systems, and basically that header propagation or the in-band communication to standardize that. It slightly renamed things. It also supports these key value pairs, but you can see it has that version, trace ID, parent ID, and then you have the sampling flags. We never mentioned what sampling was. What was sampling? So the assumption is tracing is expensive because it collects so much information. And the assumption is also you have a lot of requests. So you might not want to collect all of them, because you have lots of them that are kind of duplicate. So the assumption is you have millions of requests, and you say like, I only want to sample 1% of them, because that's still representative for all the requests that are coming into my system, but I can store those and compute those at basically 1% of the cost of collecting everything. And it will still be a representative set. What is the right sampling value for you really depends on how many requests you have, and also if you might want to, or if you could miss something or not. For some, it's like collect everything, store it for a short amount of time, and then throw everything away. For others, it's like, oh, we sample at 1%, and we keep it a bit longer just to have more comparison. It really depends. Sampling, by the way, is another hard problem that you could probably do a full talk on. So most systems do head-based sampling. It's basically the request comes in. The first system that generates that request ID makes the decision, do I collect this information, yes or no? And basically, it could flip a coin, for example, and say like 99% of the requests are getting thrown away, so we're not collecting any information there, or we collect this trace, and then it sets a special flag, and then this gets sampled. Is that very smart? Not really. Like, I mean, the coin flip is very simple to implement, but it might not be very representative. And then there is, for example, tail-based sampling, where you could say like, I only make that decision at the end. So I will collect all the information and send it to that centralized place at first, and at the end of the request, I make the decision if this was interesting. And interesting normally means it had an error or it was slow. Or to put it the other way around, with tail-based sampling, you don't have to collect all those fast, successful requests because they're probably not going to tell you much anyway, but you're focusing your efforts on what was slow or failed because those are probably much more interesting to debug. And then there are even more advanced strategies where you have like, you want to collect every type of requests at least a couple of times before throwing them away. So if you have like a batch job running at night, you would always want to collect those just to have a representative sample. So with sampling, you can still do a lot of things here, and it's just one more flag in a trace. So now coming to OpenTelemetry, what we actually wanted to talk about. It's an open source project. It's another CNCF project. It tries to combine traces, metrics, and logs, though traces are the most mature ones, so these are the ones I want to focus on today. It is trying to unify instrumentation and kind of like these so-called pillars, and I'll do another talk tomorrow why it's actually not 3 pillars in observability, but that's another story. And OpenTelemetry, abbreviated Otel, is replacing OpenTracing and OpenCensus, which was a Google implementation. It's kind of like trying to unify more, but also put everything together. And now it doesn't just standardize like the wire protocols, but also the agent libraries itself, because the assumption is, why do I put into my code to instrument various libraries from one specific vendor, and if I want to switch out the vendor, I need to rip all of that out and replace it. It's like for logs, you generally use a standard log library for your programming language, and then you just switch out the logging backend or where you redirect the logs, but you don't have to change anything in your application if you switch out the logging backend. And kind of the same thing is going for Otel, where you have a standardized integration into that tracing, and you don't need to rip out the specific implementation. It is vendor neutral, but widely supported by vendors, and lots of vendors are included in building it. So these are just some of the many that are in there, but almost everybody in that observability space is more or less standardizing in OpenTelemetry right now. So, what is the status of OpenTelemetry? And this changes quite frequently. So in a week or so, check OpenTelemetry IO status because it might be different again. Tracing is mostly stable, both from the specification and also the libraries that you can use, or at least for most libraries. So for example, the Java library and many others are stable. I think, for example, the PHP library is in an alpha state for now. Does anybody know why PHP is so special in terms of tracing? It's probably because or maybe it's the same thing in other languages, but it's the only one I'm aware of. It's because the agent is written in a different language than the language itself. because in PHP you need that weird C extension to do tracing in a performant way because of the request way they're handling. That's why they're always kind of like so far behind everybody else, because in all the other languages, if you write an agent for Java, you write it in Java, so you have people who know that. If you want to write it for PHP, you suddenly need to find a C programmer, which makes it a lot harder to make that happen. Anyway, metrics are from the specification in a feature-free state, but the agent in implementation in Java and any other language is still experimental. And logs are still only in the draft state, so the thing that you can use today is definitely tracing, maybe look into metrics. Logs are not in a usable state yet. But the idea is that all of those three will be combined and can run through the same agents. So, how can your application integrate into OpenTelemetry? And there are actually 3 different ways to do that, and the vendor can implement one or more of these. The first one is you have your application in whatever language, maybe not PHP, but all the other languages, and you have the OpenTelemetry agent. And then in that agent, so in the agent of every language, you have the so-called vendor exporter that can talk to whatever backend of the vendor you're using. So OpenTelemetry is providing these agents and also has like the wire protocol, but the backend is still always one specific observability vendor. And here, in this scenario, we're speaking the vendor protocol. So everything is kind of like from the vendor after the agent. What is the big downside or complication of this? You need someone to write that vendor exporter for every single programming language, and you need to constantly maintain it, which can be costly. So this is something that some do and others try to avoid. Instead, what you could do is there is something called the OpenTelemetry collector. So the agent speaks the OpenTelemetry protocol and sends it to the OpenTelemetry collector, which is like a centralized, I don't know, proxy or something like that that you can run. And then you can have that vendor exporter in the collector. So here, rather than having to implement it in every single agent, you only have to implement your exporter into one single component, which is, of course, much less work and much easier to maintain. This is what we have done for starters because it was the easiest to get going. So you have your exporter, and then you have your vendor protocol behind it. What else could you do? Like, could you make it more or less complicated? Yes?
The vendor could collect OpenTelemetry protocol.
Yes, exactly. So the kind of like, I don't want to say the final state, or you can kind of like push the vendor even more back. So here, just as you said, we speak the OpenTelemetry protocol all the way, and the vendor just takes that wire protocol and implements that. So here is really the wire protocol that you need to speak and be able to collect, and everything in that system here is OpenTelemetry. Even using the OpenTelemetry collector, and you can decide in your application if you want to forward your information directly from the agent, or if you want to send it to a collector and then the collector forwards it. This is actually pretty common, especially if you have different data centers or different availability zones, that you run 1 or 2 of those per availability zone, for example, to kind of like aggregate it before sending it out to a central place. Also because in your applications, as you can see, there is nothing vendor specific here anymore. And if you configure it through an OpenTelemetry collector, and that's what I'll do in my demo afterwards, you can basically just point these to an OpenTelemetry collector, and then the only place where you ever need to touch anything vendor specific is in that OpenTelemetry collector for forwarding the information. But otherwise, your applications are just using OpenTelemetry, and if you would want to switch out the observability vendor in the background, you only need to change it like in the forwarder and you're done, which has its appeal. So, yeah, like I said, our integration looks something like this, that like many others do. You have the agents, including the OpenTelemetry collector. We speak the wire protocol, and then you just take in that wire protocol. And this is what I will be using in the demo as well. Links for all the stuff that I put together. I'll be using Java. Who is using Java? Yes, the old people. No, I'm sorry. I'm just using Java, maybe because I'm lazy, I don't know. Because Java has this nice property that normally you have this, those who have never seen Java, like there's normally this one entry point into a Java program that is public static void main. And Java has this nice agent concept where you can basically say, I use a different entry point, and I use or add that agent only at runtime. So with that agent main, it's basically another method or way to start your application, and then you can instrument your application when starting it, which can look something like this. So what is relevant here? I'm using Java, and I am using my whatever package I'm using here. And what I'm doing here is, I didn't instrument my application beforehand, but I'm using this -Java agent concept where I'm basically pointing to the OpenTelemetry Java agent. I give it, these are just configuration values, so basically I say this is like an authorization token, this is the backend where the information should be forwarded. These are some key value pairs that I want to attach to it, so this is a front-end service in version 1.0 in production. And this is all the instrumentation that you need in the most basic way for a Java application, because you have this -Java agent concept. So you can instrument that just at runtime. In most other programming languages, you don't have this concept, so you always have the OpenTelemetry as a build dependency. I think .NET Core also has a similar concept where you can have like this runtime instrumentation if you want to for the entry point. All other languages need to have a build dependency somewhere for OpenTelemetry. It's still standardized in OpenTelemetry, but you still need to include it in at build time. In Java, you could, if you don't have any deeper integrations, you can use it just at runtime. So, yes, this is the very small service that I want to use. So we have a front end, we have an anti-fraud service, so it's like a very little web shop. It's talking to Postgres. I have something that generates some load. I also added a little gRPC application here as well. All of those are instrumented and forward their information to an OpenTelemetry collector, and that one, this is actually wrong because this here is the OpenTelemetry protocol and we're just forwarding the OpenTelemetry protocol. We have updated that. So let's see what we have here. So I have running OpenTelemetry, and this will collect, hopefully no errors. This will collect all information. So what I have collected in OpenTelemetry, as I've said before, what you basically do is this large enough for everybody to see? Yes, right? I'm running my OpenTelemetry collector here. So this is where I point all my applications to say like, hey, forward your information to that endpoint. And then I have in the exporters, I can configure whatever backend I want to use. So this is the only place where I have any vendor-specific stuff. So for example, for Plastic, you would then say like, this is the endpoint where I run that server to centralize it, and this is the authentication token, and yeah, don't send me any stupid messages on that token, but I will reset that environment afterwards anyway. And I say like, oh, we're using this protocol in a batch, and we're forwarding the OpenTelemetry protocol. So what you do in your Java application, and let me find my front-end service here. There is somewhere, there's a run. What we're doing here is, I'm running my front-end application, and then I say like, hey, here use this Java agent to forward it. And here, this is just, and I'm using environment variables to keep it flexible. This is that OpenTelemetry collector endpoint that I've shown you before. So even to run that, there is only OpenTelemetry stuff in here, and the only place where I have added any vendor-specific backend was in that OpenTelemetry collector endpoint. This also makes it very convenient to set up that demo because I only have a single place where I need to update it once I take down any resources in the background. And then it will start forwarding that information. And just to show you what do we even have here. So we have a very simple application where you can put something in your shopping cart. Let's say we want to add 4 TVs to our shopping cart, and then we can check out. And when I pay, the fraud service is basically doing a random number generation, and the higher the price for my item is, the more likely it is to reject that transaction. So if I buy an ice cream for $1, it's probably passing. If I buy 4 TVs for 1,200, it's maybe rejecting that. And it's asynchronous, so you might see that it at first says rejected and then kind of switches to accepted. Let's see what it does now. Okay, now you saw this one passed. We will need to do it a couple of times to get to a failed one, but I don't want to make you wait for that. We can actually instead, I have this thing that generates some load. Did I keep that running? Sorry, that was the wrong window. This window is what I want. So we are starting this thing that will just generate some load. And every little dash, I hope you see that at the bottom, every little dash is like a successful transaction, and every little X is a failed transaction. That's just like what the number generator does. And you can see I also have stats like we're using PayPal and Visa and whatever else, and how many of the transactions were successful or failed. And this is just generating load on my system, so I don't have to click around, and we still see something. So our application is instrumented, and then you pick one vendor backend to show how this looks like. You can probably guess which one I'm using, but doesn't really matter in terms of, come on, in OpenTelemetry features because they're all the same. So as I've said before, we have the 3 services. We have a front end, an anti-fraud, and the checkout service. And as I've just started that load generation, you can see those 3 are increasing, and some of them have errors here, and then you can click into one like the front-end service. The front-end service is especially nice because, well, okay, we just started to get some load here. You can see how many requests we're doing and what API endpoints are being called. It also can tell you something like, this is how long it takes, and this is what the throughput is. So this is probably the one endpoint you want to focus on first. So basically it's like latency multiplied by the number of requests, and that's like what is the highest impact in terms of making your application faster, just to tell you little things like that. It can also tell you how many of the transactions failed or what is the current error rate. So if you deploy, then you suddenly see, oh, something is spiking here. But let's look into the specific transactions that I'm running here. Down here you can see these are the 2 endpoints or APIs that I'm calling mostly. Let's look at API endpoints. This is the latency histogram of all the calls against this endpoint. So you can see this is the currently sampled latency. You can also see like the P 95% or 99%, whatever you want to see. How long do your requests take? So this is already more than a second, which is not so great. And then you can see for one specific request that we have picked here, and we could switch to one or the next, you can see, was this successful or did it fail? And then you can see which services were involved in that request, front-end, anti-fraud, or my checkout service. You can see this is the entire request. How long did it take? So my entire request that gave me back a 201 took 144 milliseconds. And then you can actually see where did you spend your time, in which service and on which calls, or what did you do. So you can see we are doing some database transactions here. And I mean, yeah, you can click into those and you can see, okay, this was a query against Postgres, and it was so fast that it's probably not even worth counting, but we have added some order here into Postgres. And you can see, okay, these database queries are all running and they're fast. And this is kind of like the parent service. So this starts the transaction and you need it to at the end as well because this is the front end. But where do you spend most of your time? Actually, you seem to spend most of your time of the 143 milliseconds, you spend 100 milliseconds or even slightly more in the check fraud service. So that is actually what is slow here. And then you can look into why this is slow. You can also see like, okay, these were all fast, the checkout was fast, the place order service against the external service was fast. This is what was slow. So you might want to have a look at that check order call here. And I think this is a very stupid example again because it has a random weight in there to just make it a little slower because otherwise there's not enough load on my system. But you can look into this part that is slow to see why is it slow or what is this doing here. You can see where this is running and what information we are collecting on that here. So you can see instrumented with OpenTelemetry on that version, where it's running, what the URL parameters were, how to figure out what this is doing and why it might be slow. The one thing that I also wanted to show you, I think it's this request in the metadata. This has some additional other things that make looking into or figuring out what is going on here a bit more interesting. We have these labels like shipping country, and we have a fraud score, and we have an IP address, and we have a price. Where could that be coming from? Yeah? Yes, and I manually instrumented that. So while a lot of the rest, what I've shown you at first, like there's a Postgres query, and this is the Postgres query because OpenTelemetry understands how that JDBC query is being done in the background. And it's talking to that service and it's propagating to that other service. All of that is built into OpenTelemetry and just works out of the box. There are still scenarios where you want to add some custom information to that to make more sense out of your data. So just to give you an idea of what that looks like, where is my front end? This is what I want to show. So in my transaction where I create that request, I am also adding data to that event. And again, this is all OpenTelemetry, so you're not dragging in any vendor-specific code into your code base, but this is just based on OpenTelemetry. For this, obviously, you will need to have a build dependency in Java as well, because you suddenly use the namespace of OpenTelemetry. But this is how you can add manual metadata to an order. So for example, I decided for my order to make sense out of that order, I want to manually instrument that with a customer ID, the order price, the payment method, the shipping method, whatever. And this is the information that you then get here, where you get the fraud score and the country and whatever else. So these are the manual instrumentations to make more sense out of those. And then you can filter, for example, give me Gesundheit. Give me all the fraud scores that are smaller or higher than this. Or give me all the prices that are lower or higher than this. So you can narrow down that data with some custom annotation where that makes sense. And if you have a backend that allows for search, you can just slice and dice your data any way you want in there. So while it's not always necessary, you can add any manual instrumentation. Also what you can do, let me get to my slides. If OpenTelemetry doesn't understand one of the spans that you're calling, you can also manually instrument a span. So for example, you can say like, I want to have my span and I want to start the span here and I want to end the span here. So you can also add manual spans in your code base if you think this thing here, whatever is happening in here, should be explicitly traced or manually traced by you. Again, this will be a build dependency because you have that namespace, but you can just add that in your application. But out of the box, OpenTelemetry will kind of like understand most common frameworks and databases. And there are more and more being added all the time. But if you have anything application specific, you can always jump in and kind of like add that if you want to. Any questions so far? Because I think I've been speaking non-stop for 45 minutes. Everybody's still awake? Maybe. Okay. I hope that kind of makes sense. Like you can see which services are involved in this call. You can see what is the metadata that I have collected for this call to then figure out what do I need to change or fix in my application here. For example, what were the URLs? Did I have any user data or user agent data? So since this is just a a spider to call this. It's not user specific, but for example, if you have React and then somebody is using an old version of Internet Explorer and everything is slow, you can even figure that out by users knowing what user agent was calling something. You can, for example, say like, oh, I'm only interested in these slower requests. I don't care about the other ones. So you have 117 slow requests, and then you could just look into like, what is the timeline for a slow request and why was it so slow? Or let's actually change that and let's look at this one single slowest request here. So this was the slowest request, and I can now, I know what was the slowest request in my system, and I can figure out why was it so slow, because that orders create took more than 1.3 seconds, because yeah, the anti-fraud check controller here took more than 1 second to respond, mostly because I think it was just using a sleep in here. Not because anything else was taking a long time. But with information like that, you can see where are you spending your time, are you running into any errors, and maybe what is causing that slowness. Let's see for this one, okay. We didn't get a good correlation here. We also have a feature where we can basically correlate latency or errors to other behaviors, which doesn't really work here because one single system is always creating the requests. But if you have like a specific user agent that is causing slowness or a specific system being involved in a request, it could automatically figure that out of the collected data. Since all my requests here are the same, there is no specific outstanding correlation for why this request was so slow. You could also look at all the errors that happened in your system, and the only errors that my application had was this one, and you can see, yeah, this is the right stack trace for this error. So all of that is being collected by OpenTelemetry, and you can hopefully make more sense of what is happening in your application, rather than just looking at specific log lines and trying to piece together what was slow or where were errors happening. Okay. So, what are your general options to run this? So there are a couple of vendor-specific APM libraries or tracing libraries. There's normally some more kind of like configuration sugar around from the vendor-specific ones. Like, for example, we would have central management of like the sampling rate, or we have more profiling capabilities, and those are things that many have, or many many tracing vendors have in their backends to have additional features. But it's still a vendor-specific thing, and people have been using those for quite a while. So if you were using New Relic or Datadog or whatever else, you might have vendor-specific tracing libraries already in use, and they probably have some features that are not yet in OpenTelemetry. However, it looks like everybody is more or less converging on OpenTelemetry just because it's so appealing that in your code, you only have that vendor-agnostic library and nothing else. OpenTracing is pretty much dead, so we can skip that. Yeah, the Jaeger protocol is almost standardized, so a lot of backends could also take in the Jaeger wire protocol. But since Jaeger is also kind of like not the way forward, let's skip that. OpenTelemetry looks to be like almost a new standard for at least tracing. Metrics and logs we will still see, but potentially as well. Or at least logs and metrics are much less mature. But for tracing, it looks like OpenTelemetry is the thing that everybody is trying to use, and that agent is also seeing a ton of development and is improving a lot over time. And I'm not weirdly jumping when the screen fails, right? I'm always wondering if I should do or should not do something for the screen to black out. So, to wrap up, why did we use distributed tracing? Because we want to be able to debug our distributed systems, and as a vendor, you love it. No, joking aside, if you have a more complex application, you probably want tracing to some degree, just because specific log events are not showing you really what is happening where. Metrics might show you that everything is slow, but it's very hard to pinpoint why something is slow. And tracing is adding that additional data to make pinpointing problems much more easy. However, it is also much more expensive because it's much more information to collect. That's why you might use sampling to kind of like cut down on that information. What is the right sampling value really depends on your application. But you want to have more of that in-depth view rather than just components spitting out some numbers. Everybody loves OpenTelemetry. Like, I could probably put any vendor logo at the bottom here because everybody is saying like, oh, OpenTelemetry is what you should use. And then all the vendors are basically competing on the back end to have the nicer visualization, the cheaper storage, the more performance storage, whatever. So kind of like the race here moved a bit away from how do I instrument my application because that is standardized, to different vendors saying like my backend has these advantages and this is why you should switch to my vendor backend. Because the backend is not a standard, but always specific to one specific vendor. That's kind of like the state where we are. And you can use OpenTelemetry for free today. It runs pretty much anywhere, on-premise, on cloud. Traces are there. Logs, metrics, maybe uptime at some point are more in the making, but traces are what you can already use today. So, we still have a couple of minutes left for questions. If you want to get the slides, I'll also push the updated slides, but this is the QR code where you can get the slides. If you want to have any stickers, I put stickers there. Take as many stickers as you want, so I don't have to carry them back to Austria. Any other questions? Or is it time for coffee? Yes, please.
What about dynamic instrumentation? You only show manual instrumentation. Could I instrument the application on runtime so I'm having a commercial application in Java, I have to figure out how to instrument it?
Yes, so there are two things there. So, I mean,
1 second, please. Could you repeat the question?
Could I repeat the question? So the question was about runtime instrumentation. So I mean, for Java, you have this runtime instrumentation, which does not exist for most other languages, because especially for Ruby and Python, you basically need to create that start point in your application. So wherever you start your application, you would need to instrument the OpenTelemetry library to say like, from here on, follow everything, and then the rest is automated. Stuff like Go is even harder to instrument because they don't have any concepts like that, and you need to do a bit more manual work there.
I'm only talking about Java.
Okay, for Java, you can do that -Java agent thing at runtime. If you put this in a container, you would still need to bake in that agent into the container and start it the right way. There are also ways to automatically attach when you start the application, even in, so I know we had an interesting blog post of when we started the container with the Java library and you started the jar, there is a way to basically attach another container with the agent and then add that really at runtime. But it can be a bit more brittle and harder to get started with. So within your own code, you want to have dynamic instrumentation?
Yes.
Yeah, I'm not aware of anything there. I think you always need to rebuild and redeploy your application. Were you using some system in the past that was kind of like automatically replacing the classes for that instrumentation, or? No, that was more of a question. No, I don't think OpenTelemetry has anything like that. So if you have like manual instrumentation in your code, you will need to rebuild your code and redeploy your application. The -Java agent concept works at runtime, but it's just like the generic framework features that it can collect. And the other languages don't have that at all. So there it's really manual. Yes, yes. I mean, yeah, probably you could decompile the Java and then maybe change something there, but you don't want, you don't want to do that. No, but OpenTelemetry also doesn't have like a magic fix for that, or at least not yet, maybe never, I don't know. No, but you can do that Java agent thing, and basically the power of the Java or any library here is that it understands like common frameworks. What common is really depends, like you need to basically read the small print and what they under support as of today. And then you have different frameworks and application servers and queues and all the others. And normally if you're using Spring Boot in the Java ecosystem, everything works magically. Once you don't use Spring Boot anymore, it gets a lot rougher. So I know that one of my colleagues really loves Javelin, which is like everything is done at compile time and it's very fast because of that. But instrumentation sucks because nobody else is using that. And the frameworks just did not build that Javelin support because it's not that widely used. And then you basically would have to instrument everything manually. So that kind of like the magic is in what is kind of like widely used and widely supported. Everything else is up to you. And if you have like some obscure jar where you don't have the source code that is using some old framework, probably you're not going to see a lot of stuff out of that. I mean, you can try, and maybe you get positive surprises, but it might not happen like that. Any other questions? I think we have 3 minutes left. Last chance. Otherwise, thanks a lot for joining me. Don't forget the stickers. Wait, I normally try to take a picture with you so I can prove that I've been working today. Can you wave? Thank you. So proof of work done for today. If you have any questions, find me. Happy to answer anything. Thanks a lot for joining.